Now we'll discuss about pointers and one-dimensional arrays. So if you observe this concept of pointers and one-dimensional arrays, first I'll show you how this pointer can be used to access the content inside this one-dimensional array. Okay. So whenever I declare an array, let us suppose int a of 5. Okay, so you can observe there will be 5 contiguous memory locations. So you can see this is an array called a. Okay, and this is indicating the very first location, then a of 1, this is a of 2, this is a of 3, this is a of 4, like this. Now using pointer you can access content inside each of these locations. Okay, so let us suppose I want to store at compile time the list of values inside this array. Suppose if I store like this 10, 20, 30, 40, 50. So in this case these are the values that are stored. 10 will be stored here, 20 is stored here, 30 is stored here, 40 is stored here, and 50 will be stored here. Now consider the base address. Let us suppose this is the base address of the array, which is 2000, and this is 2004, as integer is occupying 4 bytes. This is 2008, this is 2012, and this is 2016. These are the corresponding addresses. Now using pointer we can actually point to the base address of the entire array. Okay, so this can be indicated, let us suppose using a pointer variable. So consider int star ptr. So ptr is the pointer variable I'm using, and this ptr can point to the base address of the array, address of a of 0, for example. You can store like this, address of a of 0, or simply a itself. A is representing the base address. Okay, so now when you perform this action ptr equal to address of a of 0, it is going to consider this pointer variable called a ptr. Okay, and it will store the address of the base address of the entire array a, or a of 0 corresponding address, which is 2000. This will store 2000, and ptr will be pointing to this memory location. Okay, now using ptr you can access each and every element inside the array. Okay, so for this purpose I will take another loop variable called I. So I'll write a sample for loop to iterate and access each and every element inside this array with the help of a pointer. So I is equal to 0, and then consider I less than 5, because there are 5 elements inside the array. Now using printf statement we can display each of this element. Printf %d /t. Now I'll display ptr is pointing to this location. How can I get the element? So when I'm in ptr I'll get 2000. When I write a star ptr I'll get content inside 2000 memory location, which is 10. And after that I want to access this content called 20, then 30, then 40, then 50, like this. So in such case I value, we are going to use that updated I value and write star of ptr plus I, star of ptr plus I. So this I value will be iterated starting from I equal to 0 up to I is equal to 4, and this is a star of ptr plus I. So when I mean star of ptr plus I, this is actually equivalent to, okay, so you can observe star of ptr plus 0. So this is equivalent to writing a of 0. Okay. And when you consider I is equal to 1, this will become star of ptr plus 1, and this will be equivalent to a of 1. Okay. And writing star of ptr plus 2, where I is equal to 2, in this case it is equivalent to a of 2, and so on. Similarly, you can see here star of ptr plus 4, this is nothing but a of 4. Okay, like this. And if there are n number of elements stored inside the array, so in that case you can simply write star of ptr plus n is equal to a of n. Okay, or it can be k, simply ptr plus k is equal to a of k, like that. Okay, so now let me basically read the entire content of the array with the help of pointers itself and display the content of the one-dimensional array. So first take the header file, and inside the main function I'm going to consider an array here. Okay, so consider array is a of 20, for example, and I'm using two variables n and I. So inside n you can store the number of elements or length of the array. For this purpose you can print the statement enter number of elements or simply enter array size. So using scanf statement you can read that particular size into variable called n, address of n. Now we can prompt the user basically to read, okay, or enter those many elements. So here you can ask enter percentage d elements, so which means n elements we are asking the user to enter. Now using for loop I'm going to access, okay, so directly here I'm not even taking any pointer. So using array only I'm accessing here I equal to 0, I less than n, I plus plus. Now we can store using scanf statement. So this is scanf percentage d a plus I. Okay, so we are storing inside the array. And now when you want to display similarly using printf, you can just say displaying elements of array. And after that you can simply use this for loop I equal to 0, I less than n, I plus plus. And using printf statement you can display like this percentage d star of a plus I, content inside that particular address is obtained, and you can close this main function. So this code is basically for reading with the concept of pointers, and this is using okay, concept of pointers, we are displaying the content of one-dimensional array. Or you can directly take another pointer and point to this base address of the array and start iterating. Okay, so either the way you can do it. So let me show you with an example, okay, where I will modify and show you different ways So let us consider accessing the content of the array here. So in the main function, I'm considering a array here, that is a of 20 comma, okay, n comma I. Now I'll prompt the user to basically enter n value. So once you enter n value using scanf statement, you can read it into variable n. Okay. So later you can prompt the user to enter %d values, and exactly you need to get n number of values. Okay. Then using for loop, you can start storing these values inside this array with the notation of pointer notation. So using scanf statement, you can write like this: %d simply a plus I. This denotes here a plus I is nothing but address of a of I, address of a of I. So you can see here a plus I is equivalent to address of a of I. Okay, just like this. Now here similarly I want to display this content. So using printf, you can just display array elements, and again using for loop here. Okay, and instead of scanf you have to use printf statement to display the content. Printf %d star of a plus I. This will give you the content inside that memory location. Okay, and if I write like this, this represents a of I means it is equivalent to star of a plus I. Star of a plus I is equivalent to a of I. So let's run this code and see the result. Okay, so here we have to use a semicolon. Yeah, enter n value. I'm entering n value as 5. Now it will ask you to enter 5 values. Let us suppose 10, 20, 30, 40 and 50 are the values I have given. So you can see the same values are getting printed. Okay, so I'll use here a %4d so that there will be some space while displaying the elements. So this time I have entered 6 as n value. So consider different values like 12, 34, 23, 56, 63, 42. Okay, these are the 6 elements I have given. Now you can see displaying array elements 12, 34, 23, 56, 63, 42, same. So instead of writing star of a plus I, okay, you can directly write a of I. This is a general notation where we have used till now while working with arrays. Okay, so address of a of I. Let me show you here. In arrays, this is the notation we have used. Suppose n value is 4, 12, 23, 45 and 56. You can see the same values are displayed. Okay, and now instead of using the array name directly, you can also use a pointer, separate pointer, an integer pointer. Okay, where you can use this ptr to point address of a of 0. Okay, now using pointer you can access everything here. Simply write ptr plus I, and here instead of writing a of I you can write star of ptr plus I. Okay, so this will also work, and this time I have given n value as 5. So elements are 10, 20, 30, 40 and 50, and you can see displaying array elements 10, 20, 30, 40, 50 like this. Okay,